Hello and welcome to another one of D's ADD videos. Today we're going to look at some slightly more advanced radical problems. And here we've got a cube root function, so we look for perfect cubes. And in this case, numerically, this is 8 times 5. 8 is a perfect cube. 2 times 2 times 2 gives you 8. And then I'm going to put the 5 here. The largest power of A divisible by 3 is 9. Ooh, I should write my answers in red, sorry. Let me backtrack a little bit. So there's the 8 and the 5. And then the largest power of A divided by, or divisible by 3 is 9. B has nothing divisible by 3. And then C, let's see, 6, right? And then you're going to have 2 of them left over. The idea is that if you were to multiply this back, you would get this up here. They're still both under the cube root at this point until you take the cube root of the first one on the left. So you're going to get 2a to the third c squared when you divide those exponents by 2. And then you have the cube root of 5b squared c squared. Okay? There's your answer there. On this one, you want to pull out any perfect squares that you might be able to individually and then work your magic on what's left. So here we got a 4. We can take out a b squared. We can take out a c squared, and we'll be left with a 3ab. And then that's going to give me a 2bc. 3ab. And then here we have another completely different problem that has, let's see, again a 4, and only a c squared can come out of that, times what's left, 6a, b, and then one of the c's that did not come out with the c squared. So when you bring that down, that becomes 2c. Then you multiply what's left. Coefficients give you 4bc squared, and inside we're going to get an 18a squared b squared c, and you can pull out a 9a squared b squared, be left with a, let me bring the rest of this down real quick, 2c underneath the radical. And then when you simplify that, ran out of space, you're going to get a 4bc squared times 3ab. All I did was square root this term right here. Divide the exponents by 2, in other words. Square root of 2c. Here you're going to get 12a b squared c squared root 2c. Okay, now let's look at these two down here. On these, I recommend canceling what you can, so I'm going to write it like a single radical just so it's a little bit more evident that you can cancel. Let's see, 14 I believe goes in there 4 times if I'm not mistaken. So the 14s can cancel. One of the a's can cancel, leaving me a to the 4th up here. Both b's, and then one of the c's. So when I simplify, I am now left with a to the 4th on top, c squared, and then on the bottom I'm left with just the square root of 4. All the letters canceled out. So these all happen to be perfect squares, so you don't even need to do any rationalizing on this one. You just take the square root of everybody and you're done. Okay? One last example. Here you're going to FOIL, so it's going to be this one times this one first. So it'll be 2 root 3 and I'll just write it out for you guys just to see the steps. And then the outer, minus 2 root 3 times root 2. What was this one here? Then the inner. If you prefer doing the box method, that's fine. And then the last. So when you multiply here, you're going to get 2 times the square root of 9, which is 3. Or if you want to look at it as the square root of 3 times the square root of 3, or the square root of anything times the square root of itself, is always that thing. So in this case 3. Here we have 2 root 6 plus root 6 minus the square root of 2 times the square root of 2 is 2, by that same logic. So we got 6. Here we've got the like terms, right? So we got root 6 and root 6, so we look at this 1 that's implied to be there, and then we get a negative 1 root 6. You don't need to write the 1 there. You do need the negative. So then when you combine, finally, you get 4 minus root 6. Alright? So just a few more examples. You can see they can get a little tricky if you don't pay attention. So practice is the best way to eliminate any fears or anxieties you might have. Do as many as you can until you can do them without getting any of them wrong. I hope I've cleared up any confusion you might have. Thank you and have a nice day.